Hi again, kids. Here is lecture number 6, Elements, Compounds, and Mixtures. You've been waiting a long time for this. I want you guys to know that you have an exam on either October 17th or October 18th, depending on your day. Okay? It will cover lectures 1 through 7, labs number 1 through 6, and even as I say 1 through 6, it might actually be 1 through 5. Know that I'm not sure. I'll tell you guys as we get closer to it how many labs you've done and how many you're responsible for. On the exam, you can use your useful conversions handout and the sig fig rules handout. I gave you those at the same time, and also a calculator, but not your phone. I don't want you guys, you can't be, watching my lecture while you're taking the exam. Okay, that's cheating. And I don't want you guys texting people or anything like that. So I have calculators available for you guys for the exam if you need it. You probably won't. Okay. And a little more about the exam. Like I already said, labs 1 through 6, maybe 1 through 5. General concepts from lectures 1 through 7, which this is lecture number 6, so you've got one more after this. And the most important thing about this exam is that you have to complete all the labs and lectures by October 13th in order to even take the exam. Okay, and actually I'm going to change that date. I'm going to put a little note over it. October 14th, actually I'll give you guys, so Friday before the exam, you guys have to have finished all the labs and lectures by the end of the day. If you don't take the exam on time, you'll get a 5-point deduction on the exam each day that you don't take it and aren't prepared to take it. Okay. So those of you that are kind of going slowly at finishing the labs, you really got to pick up the pace safely. Those of you doing things at an appropriate time, you'll probably end up with some extra time, which is great because you can study for the exam. Hooray! So anyway, particles. On the POGIL worksheet you guys did, your group agreed on a definition of the word particle. So what did your group say? Hopefully you guys came up with some kind of definition like a particle is a single atom or group of atoms that are bonded together which function as one unit. Okay, so there's lots of different things that we define as particles, but I think a lot of you came up with a definition like this. Take a second to write this down. It's really important that you guys have in your head what a particle is. So based on your definition of a particle, we want to look at elements as atoms, okay? The amount of an element can change without the properties changing. So as long as you have atoms of the same element, it doesn't matter how many you have, whether you have a little tiny fingernail's worth or an entire planet's worth of an element, okay? It doesn't change. I also wanted to show you guys this picture of silicon atoms, which this is a scanning electron tunneling microscope, which scans over the image and can figure out the electron clouds and really see the actual shape of the atoms, which I think is so cool. You guys will get one of these eventually. We'll be talking about all kinds of stuff, alkaline earth metals, lots of different things. I'll try and get you guys a nice, pretty, colorful periodic table so you can look at it according to colors and really start to memorize things, which, yeah, you guys are going to memorize some stuff about the periodic table. It's chemistry, come on. Okay, and just reinforcing some material you should already have. Compounds are 2 or more elements bonded together. So carbon dioxide. Carbon dioxide is carbon and oxygen, okay? Very simple. But how do you know what an element is? How do you know to find it in a compound? So if we're looking at compounds, there's some of these you know, some of these you don't. But if we're looking at carbon dioxide, we look at the formula for carbon dioxide, which is CO2. Okay? We're thinking about how many elements, how many atoms are in this. So we look at capital letter. First capital letter is C. So there's carbon, there's 1 carbon. And the second capital letter, O, there's O2, which means there's 2 oxygens. Hopefully you guys know at this point that the little subscript 2 or any other number means that's how many atoms of that particular element there are. Okay, for glucose, glucose is C6H12O6. Ooh, gotta I'm going to use this little tablet pen a little more because it's not working out that well for me. Anyway, we have more capital letters. We have C, H, O. Okay, so there's C, a certain number of C, there's some number of H, and there's some number of O. Okay, C6, H12, and O6. Calcium phosphate, Ca3PO4 parentheses 2. Okay, we've got to look at, there are 1, 2, 3. Okay, now, elements, you use all caps. So if you see a small letter like this, then that's going to be its own element. Okay, so they use capital letters, except for some elements have 2 letters. Okay, so carbon has just a C, calcium has Ca. Okay, so if you're seeing a lowercase letter, it belongs to the capital letter that it went with. Okay, that's, hopefully you guys have seen enough of this before that it might be a little bit familiar. It's a weird way to describe it. I apologize, but if you see a little letter, it's not A. It's not like aluminum or something. Aluminum has its own name. Okay, if you see a little letter, then it definitely goes with the capital letter before it. Okay, again, sorry for that really weird and awkward description of it, but you guys need to know that. So anyway, we've got 3 different elements in calcium phosphate. We have Ca, P, phosphorus, and O, which is oxygen. Okay, they're easily enough. There's 3 calciums. Okay, now we've got to remember as I noted up here, we have to remember the distributive property, which if something's in the parentheses and there's a number on the outside, we multiply it. So 2 times 1p is 2 p's, 2 phosphorus. And 2 times 4 oxygens is going to be 8 oxygens. Okay, so that would be the total number of atoms in calcium phosphate. So for aluminum phosphate, we're looking at the number of different elements in this. We have N, H, P, and O. There aren't any little letters, so there are exactly 4 of the pretty popular atoms, pretty popular elements. We've got nitrogen, hydrogen, phosphorus, and oxygen. Oh, wow. I'm having trouble with the pen. Okay, nitrogen. So we go back to the distributive property again. There's 1 in here, okay? If there's no number, that indicates 1, and someone's coming in. I'm going to keep going, okay? 3 times 1 is 3. 3 times 4 for 4 hydrogens, that's 12. There's 1p and 4 oxygen. Looking back at the worksheet again, you guys looked at pure substances versus mixtures. Okay, a pure substance is going to be a compound or an element, something that is just that one thing. Okay, so I put a couple different examples on one side, and I put a couple examples of mixtures on the other side. Okay, you should have noticed that mixtures are separated when you're writing things about a mixture. You'll notice that it's separated by an and sign. So it's made up of this and this and this, okay? So it's separating the 2 things because it's just a mixture, like salt water is made of salt and water, okay? When you want to separate matter, there are 2 different ways you can do so, through physical methods and through chemical methods. The first, a physical method, is a method of separations that doesn't require chemical change, okay? So when you took sand and salt and water and mixed them all together, they became a mixture because the sand didn't dissolve in the water. The salt did, but you were able to remove the salt from the water by evaporating the water, and the salt was left over at the end. So that's one method of physical separation. We'll work on several different kinds, but that's one. So in short, mixtures can be separated without breaking or forming any chemical bonds. Okay, so chemical bonding is really the heart of chemistry, and we don't need to break any to physically separate something. Whereas with a chemical method of separation, you actually have to go through a chemical change to separate something out, okay? Compounds are separated by breaking or forming chemical bonds. Okay, an example of that is electrolysis, where water, as we know, is H2O, which is a compound. You separate that by adding electrolysis. You shock it, and the hydrogen gas and the oxygen gas separate. And I will try and find a video and add that in here so you guys can see what that is.
If we connect an electrolyzer filled with distilled water to a source of direct current, we can observe a slow evolution of gases. After some time, we notice that the volume of the gas released at the cathode is double that of the gas formed at the anode. To identify the gaseous products of the reaction, we collect each gas in a test tube and check its behavior in the presence of a glowing splint. The characteristic cracking sound proves that the gas released at the cathode is hydrogen. The ignition of the glowing splint is evidence that the gas collected from the anode is oxygen, which supports combustion.
Briefly, I wanted to include a quick little riddle. I'm wondering if you guys could guess what the rest of this compound looks like by this little piece that I showed you. I'll give you a minute to think about it. Maybe in your notebook, give me a picture of what you thought it was. Yeah, you were probably wrong. It's this crazy thing. I don't even know what this is. I don't know if it's real. There's no, it has like at least 3 different types of molecules in it. But this little part over on the side was the piece I showed you, but there's no way you would know if there were a bunch of those or if it was built like this. There's no way for you to tell just by separating. So if we go back to the sand, salt, and water mixture, if you just took salt out of that mixture, the evaporate at the end, would you know what your original mixture looked like? Yeah, probably not. So there's a really good point that might come up again. There's a really point that might come up again on your exam. Couple more things. Heterogeneous mixtures or heterogeneous mixtures are not uniformly distributed. Okay, so if we mix some iron and sulfur together, they're not uniformly distributed amongst each other. They're not evenly mixed. You can easily separate that. Okay. Another example would be getting a cup of water and pouring some beans in it. Okay, the beans are just going to sink to the bottom and they're not going to be mixed throughout the water. Homogeneous mixtures are an even distribution of particles. The solute dissolves and breaks into ions, as you can see by this little MEO demonstration that I'm doing. It's a very light color. I wish I had a brighter color for you to see, but it turned it purple, and it's a very even distribution. The whole thing tastes like berry pomegranate now, which is quite delightful. And a quick note about solutions. Make sure you stop and write this down. Hopefully you've been doing that anyway. But a solution is a liquid mixture in which the minor component, or the solute, is uniformly distributed within the major component, the solvent. Okay? So I drew you guys a little picture. One that I used to remember is that the solute goes into the solvent. It's hard to show that, but it's in the picture there. That's the easiest way for me to remember it. Hopefully that helps you guys too. So with that, we have pretty much defined matter in every sense that chemists and people understand matter. We have pure substances and mixtures of pure substances. Starting with, let's start over to the right. mixtures of pure substances, we have heterogeneous, and we also have homogeneous. Which is also known as a solution, or can also be known as a solution. Okay, and we also have pure substances, which consist of elements and compounds. Which, of course, compounds can be broken down by means of chemical separation. Yay, matter! So here is the part where I give you a pre-lab, and you come in with your lecture notes and you come in with the pre-lab all done, and you can get started on the lab. So first off, I want you guys to make sure that you note the objectives and the safety of the lab when you come in. You're going to get this piece of paper right here. Hopefully you can see all of that. You get this piece of paper right here. The objectives of the lab, what I've got here is to observe chemical and physical changes, which you've been doing, to present and explain observations of changes accurately and completely, to identify and use appropriate lab equipment necessary to quantify observations, and recognize patterns in observations. That's going to be very useful to you as we move forward in chemistry and start writing compounds and equations and formulas. Okay. As far as safety is concerned, the very first part of the procedure says for you to put on your safety goggles and lab apron. You're doing very small tests here, so if you don't put on your goggles and apron, I expect that you be very careful and cautious with these materials that you're using. Okay, following are 7 questions / things you need to do for this pre-lab. Okay, answer the questions, make the table. I'm going to check that when you come in, and as long as both you and your lab partner have done that and you understand what you're talking about, I will send you off to the lab. It's all set up behind me back here. I might even include a little picture so you guys can see what the lab is going to look like when you get ready to do it. So yeah, I'm just going to let this play quietly for a few seconds each. You guys can pause it as you need to. There's 7 questions. One quick note, the next time I see you, you're going to show me your lecture notes, you're going to discuss your pre-lab questions with me and your lab partner, and then you're going to do lab number 4. It will be all set up for you. See you then.